So you can see very many familiar polymers here, very many of them. So ethylene, right? From ethylene, it's more made polyethylene. All packaging are made of polyethylene, bottles, all these things. Polypropylene, like molding, rope, carpets, all these are polymers, made on polymers, okay? All these things you guys have every day using are polymers, made of from alkenes, okay? Like fibers, paint, like, adhesives, some glue, all these things are pipes from polyvinyl chloride pipes. Also, they are used in medicine because catheters, for example, are made of polymers. Tubes for catheters are made of polymers. And Teflon, especially Teflon, because they are hydrophobic. So many things are made of polymers. Yeah, so there's a list of properties which we just discussed. So alkenes and alkynes resemble alkenes in many respects. The bonds in alkenes and alkynes are non-polar. Alkenes and alkynes with 1,4 carbon atom are gases, right? And boiling points increase with the size of the molecule. Like alkenes and alkynes are insoluble in water, soluble in non-polar solvents. They are less dense than water. This is why sometimes we can see like gasoline is like on the surface of water, right? If we mix it too. Yeah, so alkenes show cis and trans isomerization. Okay. Yeah, so alkenes are reactive, more reactive than alkanes. I'm sorry. So this is about alkenes and alkynes. Do you guys have questions? All right, so now I want to move to the next topic, which is also organic chemistry. So we'll have only organic chemistry, basically quite a lot. I want to talk about aromatic hydrocarbons, which are very important one. I'll just explain what does it mean. You guys have heard maybe about benzene ring, right? So benzene ring is what you see here. That's the benzene ring over here. Okay, and this is called aromatic hydrocarbon. And when you see a 6-member ring with double bonds in there, right? We didn't discuss anything like this before. So this is 6-member ring with double bonds. This is aromatic hydrocarbon. This is not only one. We'll go through aromatics and you will see that there are some more aromatics. For example, this order from cherries, right, comes from benzaldehyde, which is aromatic hydrocarbon. So they are aromatic. They really have some smell. This is why they are called aromatic hydrocarbons. Okay. How can we understand these double bonds in there? You can see that there are 6 carbons. So basically, this is 6-carbon ring. To understand, this is like this: CH, 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 CH. How many? 1, 2, 3, 4, 5. One more CH. This is a ring like this one. We have double bonds, okay, in there. So you can see that all these carbons are equal. So it cannot be that, somebody has like double bonds and the other one does not. So it's not like that. So these double bonds are all the time are changing the position. So they basically belong to all these 6 carbons. And you can just write benzene like this way. So it means that, all these double bonds are equally spread among 6 carbons. Okay, so it is called resonance. Well, it's not only that just this six carbon ring with double bonds is only aromatic. There are very many aromatics, and some of them are very famous. For example, vanillin, it's aromatic hydrocarbon and aromatic organic molecule. And you can see the nice smell of vanillin, right? Vanilla flavoring comes from this molecule, actually, this smell. It's a bactericidal agent, hexachlorophene, which also aromatic compound, right? Also some other famous ones like pyridine, indole, adenine. All these are very famous aromatic compounds. And it's not only limited like to 6 carbons, so it can be also 5 carbon with double bonds, okay? So this is, all these are considered as aromatic compounds. I will not like talk in details about this, but just I want you to understand and know that it's important. For example, naphthalene, maybe you have heard about naphthalene, you know, this very unpleasant smell to, you know, against, you know, there are small insects sometimes appear like flying, small flying butterflies, like very small one. And they really damage the clothes, especially like wool clothes. And to tackle them, naphthalene is like the best way. So it has smell and those insects do not like it, so they just avoid these kind of areas, okay? Very famous one is benzopyrene. So this benzopyrene is in smoke actually, and in chimney, for example, chimney smoke or cigarette smoke, this compound is in there, and it's really what is makes basically the cancer development, because it's not soluble. You can see that, I mean, it's not soluble, and organism tries to make it soluble in order to get rid of this benzopyrene, and it makes a diol epoxide, and this diol epoxide is made by organisms, which is then dangerous because it can change some kind of, it binds cellular DNA, thereby altering DNA and leading to mutation or cancer. So this is where it comes from actually. Now let's just we will not be considering these complicated molecules, okay, not those, but some of aromatic compounds we will be considering. Now let's just see how to name aromatic compounds, okay? If we have substitution, I mean, if we do not have substitution, just benzene, right? If we have 6-ring member carbon. But if we have a substitution like here, right? So then it's gonna be bromobenzene, simply just bromobenzene. If we have ethyl group in there, then it's gonna be ethylbenzene. If we have nitro group in there, so it's gonna be nitrobenzene, okay? And NO2 is nitrobenzene, so it's gonna be nitrobenzene, okay? But if we have 2 of them, so we have one bromine, the other bromine, right? So how to name in this case? So again, we start from substitution, since we have everywhere these double bonds and all of them are equal. So we'll start numbering from the substitution. And then we go to the next substitution, right? So here, 1, 2. Now look, so it's 1, 2D because we have 2 bromines. Dibromobenzene. Okay, dibromobenzene. What does it mean? So we can also write this one as ortho-dibromobenzene because the positions they occupy in this aromatic ring is ortho position. So 1, 2 is ortho position. Also, we can write it like O-dibromobenzene. Now let's look at different case. We have NO2 and Cl substitution. Okay, so say we start with NO as numbering 1. Okay, and we go towards chlorine. So it's 2, 3. So it's going to be 3 chloro. It should be 1 nitrobenzene. Okay. But since nitrobenzene is like a separate molecule, so they, people usually don't write this one. So it's just 3-chloronitrobenzene. Okay. But at the same time, now see the name is changed here. So from ortho to meta, because 1,3 position is meta, or the same as M. So it's meta-chloronitrobenzene or M-chloronitrobenzene. Okay. So okay, so
Excuse me, doctor.
yeah.
For second one, we can is possible to say that one nitro 3-chlorobenzene. Why
Yeah,
we said chloro in first?
because okay, so as I say, nitrobenzene is like a separate molecule, okay, separate molecule, and separate group of molecules, and this is considered as like a parent name. And on top of that, we put chloro. This is why it's at the first. This is one version, but the other version is alphabetic, which is unlikely. This is why
Uh-huh.
chloro is first. But most likely because nitrobenzene is like a separate group of molecules and it's considered as a parent name. And then because of that, we put on top of that substitution chloro. Yeah, this is a good question, but the explanation might be like that.
Okay, thank you,
Uh,
doctor.
Strictly speaking, you can go that way, 1-nitro, 3-chlorobenzene, like strictly speaking, but because of the reason that this is separate group of compounds. The first case is here. So now the positions are different from the first two, right? So because we have 1, then 2, 3, 4, and we have D-methyl, so it's going to be 1,4-D-methyl-benzene. And now then again, the name is changed from ortho meta, it's going to be para or PD-methylbenzene. Okay, because 1,4 position is para, 1,3 position is meta, and 1,2 position is ortho. Okay. uh, could you please mute the sound because it's all right, thanks. So one thing I really want you to remember is these 3 compounds. Okay, so you can see that we can generate many different things, but at this point, I want you to remember toluene, which is methylbenzene, phenol. I believe you have heard about phenols as antioxidants. So this is when we have OH in benzene ring, and aniline, when we have NH2. Don't be like confused with Na2. This is different thing. NO2, I'm sorry. NO2 is nitrobenzene, and this is aniline. When we have NH2, this is aniline, and when we have NO2, it's nitrobenzene. Okay. Also, there might be paraxylene, benzoic acid. This is benzoic acid. We will talk about acids, I hope, if we have time. And benzaldehyde. All these are very important in like living organisms. One more thing about, okay, so let me tell you something. So this is benzene ring, but if it is considered as a substitution itself, so say we have some kind of chain, right? So this is alkane, which is heptane, and there is a substitution as benzene ring. So then it's going to be called phenyl. Don't be mixed with phenol. This is phenol. This is phenyl. I know it's a little bit like at this point not easy to remember, but at least phenol we need to remember. Okay. Right. Okay. So now let's just see what is reactions of aromatic compounds. So this is aromatic compound benzene. We can write it in this way over here. Okay. And this is a nitric acid, HNO3. This is nitric acid. But we can rewrite nitric acids. This is HNO3. But we can rewrite it like this way. Right? It's the same thing. And in presence of H2SO4, it just, to make like acidic environment. This is only reason to have H2SO4. So in this case, we can make nitrobenzene. See here, this is nitrobenzene. So what is happening that this one attaches to carbon, and H and OH are creating water. All right, so we can make a nitrobenzene. By the way, this is used to make like 3-nitrotoluol and many other compounds. One more reaction is halogenation. It's very similar to halogenation, what we found for alkanes. For example, this one and one of the chlorine combine to make HCl. And one of the chlorines is going to attach to the carbon. And then this is in presence of iron, which is catalyst. And then we make chlorobenzene and HCl. It's not difficult, I think it's quite simple. One more thing I want also you to pay attention is sulfonation reaction. Why it's important? Because many sulfa drugs are made from this benzosulfonic acid, benzene sulfonic acid. So many sulfa drugs are made, sulfa antibiotics, for example, are made from here. So the reaction is acting with SO3 in presence of sulfuric acid, and then we make benzosulfonic acid, something like that. Okay. Well, this is just, just to have some understanding also for your knowledge why we see colors, because of this double bond electron density. I'm not going deep here, but because of the change of this double bond electron density, we can see different colors, because once the color strikes, what is the color? So when we see green, it means that something absorbs red. So if you see something is green, it doesn't mean that it absorbs green. It's opposite. It absorbs red, and complementary color is green, or opposite. It absorbs green color to show red, kind of what we see as red. But indeed, it absorbs green. Okay, the same thing. If we see blue, it means that the object absorbs orange color. So because the white light is a spectrum of different lights, right? Okay, so let's just continue. For the quiz, I'll send some topics you need to focus on, but I want to explain all these things here. But for the quiz, I'll give you the topics to study. Maybe not everything what we're talking here will be for the quiz. Okay, so don't be like scared at this moment.
What, Doctor? Excuse me.
Say?
I think remembering and summarizing this kind of information could be a little bit difficult.
Yeah, so this is what I'm saying. This is what I'm saying.
Names and
Yeah,
structure.
yeah. So listen to me.
Although your presentation and your illustration is very good,
I understand, but
when you're presenting the topics, most of us can find the structure and formula, but gathering all of this information for quiz or final exam could be a little bit difficult.
Yeah, so this is what I'm saying. I agree. So you might understand now because I'm explaining, but when it's about to do by yourself, then it's going to be difficult. I agree. So because of that, This is what I'm saying, that I'm not going to give everything here for the quiz. So you will focus only on part of the material. I'll tell you ahead. Okay. For example, on alkanes, alkenes, and alkynes, which are very similar to each other.
So how about the final exam, doctor?
So the final exam, you need to sit and study, definitely. There will be something like this about how aromatics, because we have time like 1 month to the final exam. So you need to study this kind of thing. If you don't understand something, uh, send me an email and I'll give you some maybe exercises to just practice. And yes, we will have this kind of thing in the final, but not for the quiz. Well, if we have more time, I would love to have more time. If you guys want, we can have additional class. I can definitely do it
Of course, doctor. Thank you.
and practice all these things. I can arrange the class maybe um okay at one point.
We will have just two left session, yeah, doctor?
Yeah, so we have basically 2 classes left, so time is not that much, so we can have additional class. I can send out the maybe I'm thinking about weekends because weekends is like more free. So this is what
Yeah.
I'm thinking. We can set up the one class and have some examples to prepare for the finals.
Yeah, it could be so helpful and useful for us, doctor.
Yeah. But for the
Thank you.
quiz, yes, I mean, I'm not going to put all these things in the quiz because it's too much. I understand,
Yeah.
but I just want to explain because then you can go back and see this, watch. I will upload these videos and you can watch it again if you don't understand something. Okay,
Okay,
so
doctor.
let's just continue with alcohols, phenols, and ethers because we have time. Okay, this is a little bit different thing here, but again, not very difficult to follow. Just only thing in this organic chemistry is that we should not like drop the class, and if we follow all classes, it like very logically comes to the basics. So I'm talking about basics of organic chemistry, but in itself organic chemistry is quite complicated, but basics are not that much complicated. So let's just go to alcohols. So what is about alcohols is that there is a OH group which basically determines the alcoholic character of the compound. It's called hydroxyl group, OH group. It's called hydroxyl group, okay? And it's bonded to a saturated alkyne-like carbon atom. Saturated, which means that it's alkane. So look at this one. So basically what is here different from alkane, so if I write alkane, it's CH3, CH3, or in other words, another type, it's C2, H6, right? So it fits the formula as we said, it's CnH2n plus 2.
Two.
Okay, so this is alkane, which is ethane. But if you see here, if you remove one of the hydrogens from here and put OH, you will make alcohol. That's the whole story. So you just need to remove one hydrogen and then it's alcohol and put OH instead of this. Okay, that's the alcohol, but yeah. So what about phenol? Phenol is very similar to the alcohol. Only difference is that instead of say alkane, we have benzene ring, and one of the hydrogens are removed and OH is inserted instead of that hydrogen. So if I do like this way, so all these have hydrogens, right? Hydrogen, hydrogen, and there's a C, hydrogen, 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 and hydrogen. and this is double bonds. And if we remove one of these hydrogens, and instead of this, we'll put OH, it's going to be phenol. This is the phenol. Okay. Ether is a little bit different one, but again, it's not very complicated. That's the ether over here. So basically, you can make two parts. For example, I'm sorry. So you can have CH3, for example, and then CH2, and then put oxygen in the middle and add another part of carbohydrate, and it's gonna be ether. Maybe you have heard of ether, right? It's like diethyl ether was used to use as anesthetics in the past. So this is ether. So you can see the structure over here. So if we have oxygen in the middle of this chain of hydrocarbons, binding each side of hydrocarbons, that is going to be ether. Okay. So this is just about some common alcohols. You know, we have methyl alcohol, ethyl alcohol, isopropyl alcohol, which is basically rubbing alcohol. You know, the smell in the hospital, it's very often comes from isopropyl alcohol because this is what is used as a rubbing. You know, and as you know, alcohols are often used in medicine. As I said, for example, isopropyl alcohol, right? And you can see on, you can buy on in pharmacy like ethanol 99% because it's like medical for medical use. There are some alcohols, they have two hydroxyl groups and they are called D-alcohols. Okay, for example, ethylene glycol, it has two OH groups and it's a colorless liquid that is miscible with. By the way, these low molecular weight alcohols are miscible with water, so you can dissolve ethanol in alcohol, right? Basically, the alcohol which is in the shop, in the wine or some other alcohols, they are basically a mixture of water and alcohol, right? Yeah, so so this ethylene glycol also in the past it was used for purposes in automobiles as an antifreeze, but now it's like changed with a different one. Now let's just see how to name alcohols. Okay, how to name alcohols. Again, the approach is very similar as for every naming, every type of naming. It's very similar. But what is now priority here is hydroxyl group. So we need to identify where is this hydroxyl group and start numbering from there. For example, if we see that this is closer to the one end, to this end, for example, right? So we start numbering from here, 1, 2, 3, 4, 5, 6. And on the fifth one, we have also one more substitution, which is CH3. So we can name it like 5-methyl because this is methyl, 5-methyl, 3-hexanol. So now the letter of E, okay, it just changed to OL. So instead of hexane, it's going to be hexanol. So, okay. So letter E is changed to OL. The same thing is for cyclo type alcohol. So we have OH group. We start numbering from there. So 1, then we go to the substitution group, 1, 2, right? And 3, 4, 5, 6. But we don't need these 3, 4, 5, 6. So we can write the name 2-methyl cyclohexanol or 2-methyl cyclohexanol, if we are strictly speaking, okay? Because hexanol is a parent name. Hexanol is a parent name. Cyclohexanol is a parent name. On top of that, we put substitution 2-methyl, okay? For types of alcohol with 2 hydroxyl groups, we basically say 1,2-ethanediol, ethylene glycol, or ethylene glycol, okay? So again, I understand it's difficult to remember all these things, but I'll explain, then we'll go like maybe in more details about this. But again, for the quiz, I'll tell you what to study first. The same thing about this kind of compound, which is so this is 1, 2, 3. So it means that it's 1,2-propanediol, because we have 2 hydroxyl groups. And why it's propanediol? Because we have 1, 2, 3 carbons. This is why it's propanediol. Properties of alcohol. So it just, it's what is important here is that straight chain alcohols with up to 12 carbon atoms are liquids. And each boils at a considerably high temperature than the related alkanes. So alcohols boiling point is higher than for alkanes. You know why? Because we have hydrogen bonds in there, and it looks like water, a little bit. So there are hydrogen bonds in there to make with another molecule, and these alcohols have higher boiling point than alkanes. So big alcohols, like, for example, heptanol, like more than 7 carbons, when we have more than 7 carbons in alcohol, they are like more alkanes. You see this one, alcohols with larger organic parts such as 1-heptanol are much more like alkanes. Okay, and less like water. So heptanol is nearly insoluble in water. So more than 6 carbons, if it is more than 6 carbons in alcohol, it's not miscible with water anymore. So, okay, we can dissolve like ethylene, propanol. This is why it's like, there's 90% propanol, which means that 10% is water, 90% is propanol. But others cannot be miscible with water, okay? All right, so I'll finish with alcohols. I have 5 minutes left, and then we can just have a rest. And I'll send out the email, check the email about the quiz. Okay, so what can be happening with alcohols? For example, it can be dehydration, so taking out water. For example, so we know that alcohol has this OH, right? So if we take out the water, so then we'll make alkene. You remember we said that alkene can be hydrated. So the hydration of alcohol basically is the opposite reaction of hydration of alkene. Okay. The other thing is oxidation. This is very interesting, oxidation of alcohols. For example, after oxidation of alcohols, we make aldehyde. So this is one oxygen added, so we make aldehyde. And then further oxidation of aldehyde makes carboxylic acid. You remember maybe we discussed about alcohol opening bottle of wine. I believe it was in your quiz or something like this. So if you open the wine, and if you put the wine open for 1 month, like you deliver some wine, then you put it for 1 month on the bench, you check pH, it's going to be low. So say you check pH of wine, it was something, I don't remember, maybe it's about 5 or 4. Then after 1 month, you check pH of this open wine, it's going to be 3, right? So it became more acidic. Why it becomes more acidic? Because of this. Okay, because of this reason, it becomes acidic. So basically from alcohol, which is in wine, we produce carboxylic acid. So this acid gives pH low to the wine, like table wine. Okay. So this is what is written basically here. And this is just for some kind of some exploitation of some devices to check like alcohol degree in the blood, for example. These are information 400 milligram for in deciliter. There might be nausea after taking alcohol, but 600 milligram per deciliter in the blood, it can be fatal. It can cause a death. So from 80 to 300 milligram per deciliter, it's like maybe it's more, it can kill the pain, stuff like this, but like high amount of alcohol in blood causes death. You know what? I will stop here because maybe this is too much. And I don't think that you guys are kind of,
So
maybe.
like for today's we have a bunch of information and structures. We have a lot time to memorizing this kind of structure.
Okay,
So
okay,
doctor,
so
for next week we will have a presentation. So we will have a framework for our presentation. I mean, using structures, movie, or something like that. Or we can produce some material and present it in class.
Okay, there is a guidelines uploaded almost 1 month ago on Moodle. So in the part of announcement, there is a guidelines uploaded. Can you just go to the Moodle and download those guidelines? That's presentation. Then it says now please download these
Uh-huh.
guidelines. It says everything in details. What
Oh,
you need to do.
I didn't see
Yeah,
it.
so it's been like more than 1 month, I believe. Then I
Uh-huh.
uploaded this one in on the Moodle. More than 1 month.
Okay, okay. So for next week we will have quiz and presentation. Yeah.
Yes, I'm planning to have quiz in the morning, and then we'll go with presentations because basically we don't have much time to left. I'll find out when is your exam week, but I think we don't have much time, so we need to finish our course. And yeah, I want to fill up all points. So we'll have 10-point presentation, 10-point quiz. So we have 20 points left. Okay. I want to
Okay.
fill up this. I have less than 1 minute left, but please, again, go to the Moodle, download the presentation. Well, the time is changed. Last time I said 11. Yeah, so actually, no, everything is okay as it is in there. So please read
Okay,
that
doctor.
guidelines.
Thank you, doctor.
All right, guys. See you next
Have a
week.
good day.
Yeah, you too. All right. See you.